Hello everyone and welcome to this video on the Python programming language and machine learning. So in this video I will attempt to predict the price of Dogecoin using Python and machine learning. Now before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about new videos from this channel, hit that bell notification. Now, I'm currently on Google's website called colab.research.google.com, and I'm on it because it makes it easy to start programming in Python. So all you have to do is go to this website and then log in using your Google account and get started writing your Python code. So to get started writing this code, you're going to want to click on File, then click on New Notebook, where a new tab will open up for you, and then a new cell will open up for you. And in this cell, I'm going to put in some comments. I'm going to put in a description about the program. So I'm going to put this program attempts to predict the future price of Dogecoin. All right. And with that being said, I should also say that the material in this video is purely educational and should not be taken as professional investment advice. So be sure to do your due diligence and your research before making any sort of investment. Don't take advice from people like me or anyone else. Again, just make sure that you do your own research first. All right. So with that being said, let's go ahead and continue. So I'm going to create a new cell by clicking this code button in the top left. And in this cell, I'm going to import some of the libraries that I'm going to be using throughout the program. So I'm going to import NumPy as NP, and I'm going to import pandas as PD. Okay, now I'm going to run the cell by clicking this button here to the left, and this will let me know if I made any mistakes. All right, so let's give it a little time. It looks like it's done. Let's create a new cell. And now I plan on loading the data. So I have a data set that contains the price of Dogecoin. So I'm going to go ahead and upload that data set. So from google.colab, I'm going to import files, and then I'm going to just type files.upload, and this will allow me to upload the file. So let's click on choose files, and I'm going to upload that doge.csv file. Okay, and it looks like it's done. So let's create a new cell and let's store the data. All right, so I'm going to create a variable called df and set it equal to pd.read_csv. And I'm going to input the name of that file, which is doge.csv. And then I want to show the data. So I'm just going to type df here, and let's run this. All right, and now we can see that this data set contains the date, the high price, the low price, the open price, the close price, the volume, and the adjusted close price. And it has 138 rows of data and 7 columns. And the dates are from 12/1/2020 to 4/16/2021. And if we take a look at the close price, we can see that Doge was less than a penny on 12/1/2020, and on 4/16/2021, it was more than 28 cents. Okay, so that means that this price for Dogecoin has increased significantly in a short amount of time. All right, so I want to set the index to be the date. So here I'm going to set the index to be the date. So I'm going to set df equal to df.set_index, and I'm going to input pd dot, let me bring that down a little bit here. All right, so I'm going to input pd dot date time index, and then I'm going to input df date dot values. All right, so let's go ahead and run this. And now we can see the indexes or indices are the dates. All right, so let's create a new cell. And now I want to get the close price. So I'm going to set df equal to df close. And I guess I'll go ahead and show the data as well. So just type df here, and let's run this. And now we can see only the close price column. All right, so let's create a new cell. And in this cell, I want to create a variable to store the number of days into the future that we want to predict. So I'm going to create a variable called prediction underscore days and set it equal to 1. And next I'm going to create a new column called prediction. And this column will contain the future price that we want to predict and train our model on. So let's go ahead and create that column called prediction. And let's set it equal to df close dot shift. And I'm going to shift it in days or prediction days up. And then I'm going to show the data. So I'm just going to type df here. Let's go ahead and run this. And let's take a look at it so that you all understand exactly what I'm doing here. So we're looking at this close price here. This would be today, and tomorrow's price will be here. All right. So this is the price that we're looking at, and this is the price that we should be predicting. Again, this is the price that we're currently looking at, and then this would be the price that we want to predict, so on and so forth. And this should be the case for every single row except for the last one, where we have a NaN value because we don't have any data for the next day's price. All right, and that's expected. So let's go ahead and create a new cell. And in this cell, I want to create the independent data set. I'm going to call it X. So I'm going to set X equal to np.array, and I'm going to drop the column prediction from this data set. So I'm just going to input prediction here, and I need to tell this method that I want to do this on the column. So I'm going to input the value 1. Okay, and then I want to remove the last n plus 1 rows of data, where n is the prediction days. Okay, so I'm going to set X equal to X, and again I want all the rows except for the last n plus 1 rows. So that's the length of the data set minus prediction days minus 1. Okay, then I want to print the data. So I'm going to print X here, and let's run this. And there we go. All right, so if I just scroll down a little bit, all right, I can see that I get to the end of this data set and I have this value 0.182207. So let's go back up. Let's see where that value is in the data set, in the original data set. So here it is for this day. And I did that on purpose. So I did not get this last row of data because I'm going to use it later on when trying to kind of validate my model. All right. So the X data set will stop here. All right. So let's go ahead and create a new cell. And we're going to do something similar for the dependent data set. So I'm going to create a dependent data set, and I'm going to call it Y. Okay, so I'm going to set Y equal to np.array, and I want the data from the prediction column. Okay, and then I want to get all of the Y values except the last n plus 1 rows of data. All right, so to do that, all I need to do is set Y equal to Y, and then I want all of the rows except for, again, the last n plus 1 rows. So that's negative prediction underscore days minus 1. And then I want to show the data. So I'm going to print Y. So let's run this. Oh, look like I made a mistake. So let's see, minus prediction underscore days. Prediction days is not defined. What did I call it? Let's go back up here. And let's just highlight this, copy it using Control C, come back down, and oh, I misspelled prediction. That's what it is. So let's highlight this and let's paste it using Control V. And now let's run this. Okay, so there we go. We have our Y data set. All right, so let's go ahead and create a new cell. And now in this cell, I want to split the data into a training data set and a testing data set. More specifically, it's going to be 80% training and 20% testing. All right, so to do this, I'm going to need to use a function called train test split, or at least I want to use it. It makes it a little bit easier. So from sklearn.model_selection, I'm going to import train_test_split, and I'm going to create my variable xtrain. I'm going to create my variable x_test and y_train and y_test. All right, so I'm going to set this equal to train_test_split, and we're going to input our independent data set and our dependent data set. And then again, I wanted the testing data to be 20%, so the test size will be equal to 0.2. All right, so everything looks good. Let's go ahead and run this. Let's create a new cell. All right, now I want to use the random forest regressor for the model. So from sklearn.ensemble, I'm going to import random forest regressor. All right, so I'm going to create a variable called forest and set it equal to random forest regressor, and I'm going to give it in estimators. I'm going to set it equal to 2, and then I'm going to give it a random state. So random_state will equal 587, and then I'm going to train the model. So I'm just going to type forest.fit, and I'm going to train it with our xtrain and ytrain data sets. So that's our training data sets. And then I want to print the score of how well the model did on the testing data set. So I'm going to print forest.score x_test and y_test. So let's go ahead and run this. Okay, and it looks like our model got a score of about 96%, which is really good. All right, it really makes me question this model. But let's go ahead and take a look at those values now. So I want to show how close the predicted values and the actual values are. So I'm going to create a variable called prediction and set it equal to forest.predict, and I'm going to input the test data, the independent test data, x_test, and then I want to print the predicted test values. All right, so I'm going to print prediction, and then I want to print a new line, and then I want to print the actual values. So I'm going to print y_test, and let's go ahead and run this. Okay, and now we can see for this day here, the model predicted the value of Dogecoin to be 0.00328855, when in fact the actual value was 0.00373, which is pretty close. And then for this day, the model predicted Dogecoin's value to be 0.0095233, when its actual price was 0.010194. Again, that's pretty close. And we can keep doing this all the way through all of these values, but I think you get the idea. All right, so let's create a new cell and let's kind of validate the model. So we're going to get the validation data for the model, which will be data that the model has never seen before. So I'm going to create a variable to store all of the rows in the data set except the last n rows, where of course n is prediction days. All right, so let's go ahead and create that variable. I'm going to call it temp df, and I'm going to set it equal to df. And I want all of the rows except for the last n rows, right? So that's minus prediction underscore days. Okay, next I'm going to create a variable to store the independent price value that will be used when making future predictions. So let's call it x underscore val. Let's set it equal to temp underscore df dot tail, and I want that last row and put the number 1, and I want the close price at position 0, and then I want to show the data. So we're going to print x underscore val, and let's run this. Okay, and that value is 0.36586999891. Well, you got the idea. It's this number here that's highlighted. All right, so I'm going to just go up and make sure that that's the same number that we were looking at earlier. Okay, so I think the number should be 0. Oh, yep, yes it is. Here it is. All right, so the number is 0.365870. This, of course, is just rounding the number up. So if I go back down here, it is the same number, just rounding up here. All right, so let's go ahead and create a new cell. And what we're going to do is we're going to input this value into the model, and then the model should predict, or if it was a good model or a great model, it would predict this value here. And if it's a good model, it will at least get close to this value 0.284173. So let's go back down and let's just write a few print statements. So I'm going to first store some values in the prediction. So I'm going to set prediction equal to forest.predict, and I'm going to input that xval variable. All right, so now we have the prediction. And now I'm going to print the price of the Dogecoin for the next n days. So now let's write our print statements. So it will be the price of Dogecoin in some amount of days and prediction underscore days. And I'm going to put days here. I'm going to put days and put the S in parentheses because in this case it's just 1 day. So days is predicted to be, and then I'm going to input the prediction variable that I created. All right, next I want to print the actual value for the next n days. So I'm going to print here the actual price was, and let's get that actual price. That's temp df dot tail, and then we're going to input the number 1, and we want the data from the predictions column at position 0. All right, so let's go ahead and run this. Okay, so now we get back the price of Dogecoin in 1 day is predicted to be 0.36587, and the actual price was 0.28417. So the model is off a little bit, but that's pretty close. And yeah, so that's basically it. Well, again, that's the end of the video. If you want to start an investment portfolio of your own, then you can click the link below and get 2 free stocks valued up to $1,850 on Webull when you deposit $100 or more. And don't forget to grab $10 worth of Bitcoin using the BlockFi link below as well. It's basically free money. Thanks again for watching, and thank you to the supporters supporting this channel on patreon.com. If you want to become a supporter as well on patreon.com, or just get the code and data set from this video, I will leave a link in the description below, and I will see you all in the next video.